Chromium is going to be in an elemental state as it comes from the ore. Chromium also exists in a trivalent state, and that is the most stable form of chromium. And lastly, our subject today is the hexavalent chromium state. It exists in operations. It's also called hexchrome, chrome 6. Throughout today, I'm going to be calling it CR+6. So that's the terminology I will be using. The valence state and solubility greatly affects the toxicity. So when we talk a little bit later about the health effects of hexavalent chromium, its health effects are very different than the trivalent chromium and certainly different from the elemental form. Chromium can oxidize or reduce depending on environmental conditions, and we'll talk about why that's important. And lastly,
I'm sorry.
Yep.
Okay, I'm sorry to interrupt. I just want to remind you to show your screen.
How do I do that? Isn't it on there?
Press the blue button with the triangle and the control panel.
Is it there now?
There it is. Thank you.
Oh, I'm sorry. I should know how to do this. We talked about it yesterday. I'm very sorry. Chromium can combine with some other substances, and that becomes a little important when we talk about certain types of welding situations that you may be doing in your foundry. Okay, I'm trying to advance this slide here. There we go. Hexavalent chromium can be present in the hex state in various types of coatings. So if you have old painted products that may have had chromium in it, that exists as a hexavalent state. Also chromic acid, which can be used in electroplating operations, that exists as hexavalent chromium. But for most of us, our exposures are in the second category, or the concern is that hexavalent chromium can be created during the oxidation of chromium that is present in other valence states. So you have some metal, and it is in the elemental chromium state. Exposures to hexchrome are created when that elemental chromium is heated to high temperatures. There are other situations where chemical reactions can cause oxidation, but for the most part in foundry situations, we're going to be talking about this first category where the chromium is created during heating. So why do we care about hexavalent chromium? Well, the most notable thing that's of concern is cancer. Hexavalent chromium has long been associated with lung cancer. Did you just lose my screen here?
Yes, okay.
Oh boy, I'm really sorry. I don't know why my computer is acting up here. There we go. Cancer is the most common issue that we have, or the reason OSHA implemented this standard was because of hexavalent chromium's carcinogenicity. There are other health effects related to hexavalent chromium, and I've listed them here on this slide. Many of these health effects have been associated more with the chromic acid form and soluble forms of chromium. In foundry situations, you might have some soluble forms of chromium. More likely it's in an insoluble form. But the OSHA standard does talk about these other health effects, and I won't go through them very much other than to say hexavalent chromium has also long been associated with allergic skin reactions. The evidence for hexchrome being a carcinogen comes from these following groups of workers, as well as animal and cellular studies. Again, from a foundry situation, it's the stainless steel welding type of situations that do show some of the studies show some evidence of it. However, even in those studies, there are other carcinogens that might be present in welding situations. So the strongest evidence for hexchrome being a carcinogen comes out of the chromate production and chromate pigment workers studies. So before we start talking about where we find hexchrome in foundries, I want to just kind of lay a little groundwork here. I'm going to talk first about the OSHA exposure limits because I want to talk about those as we go along and discuss exposures in foundries, and then we'll get into the standard itself. But the permissible exposure limit is 5 micrograms per cubic meter. That's a pretty low number. The action level is 2.5 micrograms per cubic meter. And then the trigger level for the standards provisions is 0.5. micrograms per cubic meter. If you have exposures that are under 0.5, the standard actually doesn't even apply to your situation. And we'll talk about that in a few minutes again. An important thing to keep in mind is these are all expressed as 8-hour time-weighted averages, so you may have some task or process that doesn't last a full 8 hours, but if that average for that 8 hours is over these levels, then that's how you look at the numbers. So the numbers to keep in mind are 5 micrograms for the PEL, action level 2.5, and then the trigger level for the standard provision at 0.5. So let's talk about what we have in foundries with hexavalent chromium. Many of you have already probably been collecting data, if you've had, especially if you're in the business of casting higher chrome alloys, and you may actually have data out there. So, but others of you may not. So we'll start out talking first about low chromium alloys, and certainly gray and ductile iron fit into this category. And when OSHA talks about foundries as being someplace where you will find hexavalent chromium, they kind of just say foundries and lump everybody together. But we've certainly learned over the last few years in collecting data that gray and ductile iron just doesn't generate a whole lot of hexavalent chromium, and it's probably because the amount of chromium in these alloys is very, very low, and there just isn't enough of it getting into the air and causing issues. But certainly casting, melting and pouring of higher chromium alloys, and by this we're talking chrome contents that are likely in the upper teens to and above percentages in the alloy. This is where there can be exposures. There was some member-reported results from SFSA, which is another foundry association. It's not a peer-reviewed article, but they polled members and asked them to supply them with information about their sampling data. And the sampling data that was provided, again, not peer-reviewed, it's certainly not a scientific study at all, indicated that the melting of, they referred to them as stainless steel alloys, didn't result in exposures over the PEL or action level. There were exposures that were over that trigger level, so certain parts of the standard do apply. However, they didn't find much over the PEL and action level. My experience in working in doing sampling and melting and pouring operations is that this is pretty much the case, that you rarely find anything over the action level and even rarer find anything over the PEL. Now, there may be certain circumstances where that's not the case, but I think in general that's a pretty good rule of thumb. I guess the question there is the temperature in a melting situation high enough to create a lot of oxidation up to the hex chrome state from the elemental state that's in the metal? And it simply may not be hot enough to generate lots and lots of hex chrome. And there's probably some other metallurgical reasons that I'm not aware of that explain this too. That said, I think it's important that you sample your melting and pouring operations if you're pouring these higher chromium alloys to determine what, if any, parts of the standard apply. So I think it's, even though the data seems to show that the exposures are low, I think it's important to document that. If you're in a gray and ductile iron foundry, I think your chances of finding much hex chrome at all is very low. Let's talk about hot processes, and I'm going to lump kind of all these together and then talk about them individually. What I'm talking about with hot processes is post-casting of a material that contains chromium in it. So we're talking about finishing operations, repair operations, or subsequent fabrication operations where the castings might be used to form other products that your customers want. Again, we'll start out with the low chromium alloys, gray and ductile. I don't expect that even if you weld on these or thermally cut them, you're going to generate a lot of hexavalent chromium exposure. There is certainly a possibility that if you have very uncontrolled exposures during things like plasma cutting and arc gouging of these alloys, you might be able to create some hex chrome exposure. But again, in general, these alloys just don't have enough chromium in it to be a problem. We're back to then the high chromium alloys, where the exposures over the PEL are not only quite possible, they're very possible, particularly when we talk about a couple of these types of operations. So thermal cutting includes plasma cutting, particularly manual plasma cutting, arc gouging, and gas torching. Repair or fabrication arc welding, sometimes a casting has some flaws in it, and your finishing folks will take either a MIG flux core stick type of welding process to repair a casting that can generate hex chrome, and then subsequent fabrication using those castings, if you're doing that in-house, can create exposure. It appears that the high temperatures involved in these thermal processes really is what drives the formation. There's lots of stuff going on there, but the high temperatures really cause a lot of formation of hexavalent chromium. One other aside, too, something that I found is that folks who use chromite sand in their casting processes, sometimes that chromite sand, which does contain chromium in it, can adhere and stick to the casting or get burned into the casting. If you arc gouge on those or plasma cut and you oxidize that chromium that's in that stuck-on chromite sand, you can have some pretty significant hex chrome exposures. So the risk of exceeding the Pell or action level with these thermal processes, I've kind of thrown them into three categories. Again, this is based on my experience as well as a lot of experience in just the whole area of welding on high chrome alloys that comes out of industries other than foundry industries too. The high risk ones are indicated here in red: carbon arc gouging, manual plasma arc cutting, and thermal spraying, which probably isn't a very common foundry application, but all three of these can generate just incredible amounts of hexavalent chromium. And as you note in the little box there to the right, even more concerned that you can have these processes done on a short-term basis, say 30, 45 minutes, and there's enough hex chrome generated in that time period that the time-weighted average for the employee, even if they have no other exposure for the rest of the shift, can exceed the Pell. So we're talking very high potential exposures with those three red indicated materials. The high to moderate risk ones, I threw in basically the other welding processes you've done on either repair welding or fab welding. Stick welding is sometimes used. MIG welding is commonly used, and then flux core, which is kind of similar to MIG welding. If high chromium wire, and by that I'm again defining that chromium content of the wire, the consumable, is over the upper teens or into the 20s, there's a good chance you could have some significant hexavalent chromium exposures to the welder who's actually doing that work. The low-risk operations are TIG welding. You don't find a lot of hex chrome generated during TIG processes. Submerged arc, you also don't find much because the arc is actually under flux material, so there's really no place for the fumes to go. And resistance welding generates very, very little hexavalent chromium. So again, if you're doing a risk assessment, you want to focus on those high to moderate risk types of operations as to where to look for hex chrome. Factors affecting the generation of hexavalent chromium in welding, I'm not going to go through all of these, but I do want to hit upon a couple of them. Obviously, the actual amount of arc time a welder or cutter has is very significant. If it's just a little bit here and a little bit there, chances are you're not going to find a problem. But the more arc time you have, the greater the likelihood is that you're going to exceed the Pell or the action level. The chromium content of the consumable is very important. If you're using high chrome alloy wires to weld on high chrome, most of the fume that's generated in welding operations is coming from the consumable, not the base metal. So you want to look at the chromium content of the consumable as an indicator of whether or not there might be a problem. The binders that are used in some consumables, particularly stick welding operations, you tend to find hex chrome levels high in those because those calcium and potassium and other binders that are used in there actually combine with the chromium, stabilize it, and that hex chrome which is created tends to hang around a lot longer, so sometimes you'll find higher exposures from that. Certainly ventilation, which Bob is going to talk about in the next session, will be a big factor in that, and I'm not going to dwell on that a lot more other than to say it certainly is a factor. Abrasive processes are the last category that I'll talk about here. Oxidation to hex chrome from elemental chrome that's in a metal or even trivalent is not likely to occur in grinding and blasting operations. So my experience, as well as that of others, is that the exposures tend to be low for hexavalent chrome. It's not to say that you won't find a lot of chrome in these samples. It's just that it's not necessarily in the hexavalent chromium. If you have if you have grinders working on high chrome alloys in poorly ventilated spaces, maybe large castings which you can't really ventilate very well, there may be an issue with exposure, particularly over action limit types of exposures. I've seen some data that supports that, not necessarily in foundries, but in other types of operations. When you have poor ventilation, a lot of grinding dust generated, you do see some hexavalent chromium there. Same with blasting. So the bottom line here is that while I think the likelihood of overexposures is not real high unless you have these really poorly ventilated type of castings, I still think it's important to establish what those exposure limits are and determine, or what your exposures are, and determine what, if any, parts of the standard apply to your operation. So with that said, let's talk a little bit now about the specifics of the standard. Again, I'll keep coming back to how it relates to foundry operations, and keep that in mind. It's a performance-oriented standard. It only applies to the hex chrome. Again, that last statement that's up there, if your exposure, your time-weighted average exposures are less than 0.5, the standard simply doesn't apply to you, so you can rest well at night, not have to worry about it. These were the deadlines. We're way past all those deadlines, so I'm not going to dwell on that, other than to say if you have overexposures and haven't controlled them, you got an issue there. So let's talk a little bit about exposure determinations. The standard says you have to determine the TWA exposure for each person exposed. This is done through personal air samples. You can use other objective or industry data, or maybe even old data that you have. But if you're going to go with that approach rather than collecting new exposure samples, you should read through those 4 things that I have on the right-hand side of the slide, because the burden is on you to show that that objective data complies with the standard. And it may just be a whole lot easier to collect personal samples from what you are doing now. The sampling should look at full shift exposures for each shift, for each job classification in each work area where there might be exposure to hexavalent chromium. So you've done your monitoring and you've got your numbers here. Now what should you do with those numbers? Well, if you're below the action level, you can discontinue the sampling, the periodic sampling, unless conditions change that you think you might be over. Maybe your production levels increase. Maybe you never did high chrome alloys and now you're doing them. You could expect that that's a condition change, and then you should resample. If your samples are above the action level but below the Pell, that triggers you into a periodic air monitoring. If you're familiar with the lead standards or cadmium standards, it's the same kind of principle. You have to sample at least every 6 months until you get 2 consecutive samples at least 7 days apart that are below the action level in order to discontinue your program. If you're over the Pell of 5, the sampling frequency increases to every 3 months or quarterly, again, until those levels drop. So bottom line is look at your numbers and put yourself into these 3 categories. When conditions change and you expect new or additional exposures, you really should reevaluate that through air sampling. One thing, though, to keep in mind is IH exposures are inherently variable. So if you decide that you get 2 samples that are below an action limit or below a Pell, be very careful about deciding to discontinue your program. It takes lots of data to establish confidence that you're making the correct decision either to control or not control an exposure, which is, of course, what a consultant's going to say, that, we want more air samples. But the point is that, it only takes 1 sample from an OSHA perspective to be over a limit. And if you make a wrong choice, it could have some significant consequences. My experience in sampling, can you still hear me? Shannon?
Yes, Kate. Yes,
okay.
I can hear you.
Okay, I just got this weird message that something wasn't valid. Okay. My experience in sampling welders, as well as all kinds of other operations, is there's just a lot of variability between workers, the type of casting being processed, environmental factors. So be very careful about determining what is a representative sample and what those numbers are actually telling you about your exposure. Another thing I think it's really important to do is collect information about what that person was working on the day that the samples were taken. That can be invaluable information when you're trying to set up controls or trying to make decisions on what to do about an exposure. It's very important to know what that employee was doing. Maybe there's some unique casting that causes all your problems and the rest of them don't. So it's important to know that sort of thing. Just a couple more things about monitoring. Hex chrome has to be sampled separately from other welding fumes or pouring fumes and other metals. It's very important to watch the decimal points. I've been using 5 micrograms. Lots of laboratories report out their data in milligrams per cubic meter. There's a 1,000-fold difference between those numbers, so be very careful about making sure that you're looking at micrograms and milligrams correctly. The sample length, they say OSHA compares the numbers to an 8-hour time-weighted average. However, breaking apart tasks such as these higher exposure tasks to identify what might or might not need controls is very useful, but in the end you need to compare your 8-hour time-weighted averages back to the Pell. Sample methods, OSHA 215D, the latest version is not necessarily required, but my finding is that that's what labs are using. Another thing to keep in mind that there is sample loss from samples generated from hot processes, so be sure to have those samples analyzed within 7 days. The sooner the better to prevent sample loss. Surface sampling, OSHA doesn't require it, but we'll talk a little bit about this when we talk about hygiene and other things. The thing I want to say here is there is no OSHA standard for interpretations of surface sampling, whether it's a bulk sample or a wipe sample. You end up using professional judgment. They have a much higher standard of cleanliness for surfaces where employees eat, which is kind of odd because we're talking about a lung carcinogen, not a different kind of carcinogen, but that's the way the standard's written. So if you're going to do bulk or wipe sampling, you can do that. Hexavalent chromium, it tends not to be very stable, and it doesn't hang around very long. So in a lot of stainless shops where I've done wipe and bulk sampling, I don't find a lot of hex chrome because it's already reduced back to trivalent. But that's not to say you shouldn't evaluate those exposures. The key is, though, with the wipe sample, some of you may be familiar with using like ghost wipes or Palin test wipes. You cannot use wet wipe methods for sampling of surfaces for hex chrome. It won't be there when the lab is looking for it. So follow your laboratory procedures if you're going to gather those samples. One big change that occurred since the last time we did this webinar, and this happened in 2010, is that OSHA expanded the employee notification of sample results to 15 days for all samples. The original standard said you only had to do that if they were over the Pell, but this was changed in 2010. So there's a uniform notification of 15 business days following your receipt of the results. The notification must be in writing, and this is one that I don't see folks doing very often. If the exposures are over the Pell, that notification is supposed to include the corrective actions that will be taken. So let's go back to looking at the required actions, and I'm going to, instead of going through the standard verbatim, I'm going to kind of break it apart by what do your numbers tell you. So let's say you've done your sampling and you feel it's pretty representative and all of your exposures are below that trigger level of 0.5 micrograms. The only requirements you have is to keep your sampling records for 30 years. That's part of the 1910-1020 medical and exposure record standard, so that's just the standard requirement for all air monitoring. And secondly, to notify the employees within 15 days. Those are your obligations. I probably should add that if you think the exposures change, you should reevaluate the need for sampling. If you're over that trigger level of 0.5 but less than 2.5, this is the next step that you have to do. Again, the first two are the same. And here you need to add hexavalent chromium training to your HAZCOM program, and we'll talk about what that means in a few minutes. There's also this provision in the medical surveillance part of the standard that says that if an employee experiences symptoms that could be associated with hexavalent chromium exposure, you have to provide a medical examination. And I have a little bit more info on that later on in the presentation, but that is something that's kind of unique to this standard. So if you're over the action level but below the Pell, we have everything that we just talked about in that previous slide, but now it triggers the periodic sampling where you need to sample the jobs that are over the action level every 6 months. And include all employees who are exposed over that action level in a medical surveillance program if that exposure occurs more than 30 days a year. So maybe you have a very intermittent process that you don't do very often, or maybe it's a particular casting that's an issue, If you don't work on that for more than 30 days a year, you don't have to do that. But keep in mind that this exclusion for 30 days a year applies to the specific exposure. So say you have one process that you do less than 30 days a year and isn't in the action level, but those same employees work in another job where it's over 30 days a year and they're over the action level, you have to include them in the medical surveillance program. Now, if you're over the Pell, you have all these things that we've already talked about here, but now the sampling frequency increases to every 3 months. You have to immediately protect employees with respirators. So as soon as you know that you're over the Pell, you protect employees with respirators, and then do number 3, which is the starting on the implementation of feasible engineering and work practice controls if the exposures if the job or task occurs more than 30 days a year. So again, you need to look very carefully at your processes if you're going to try to use this 30-day-a-year exclusion, and the burden is on you to show that it doesn't occur more than 30 days a year if you want to not implement controls. But for many of you, if you have overexposures, they're going to occur more than 30 days a year, so you're in that implementation of controls, which Bob will talk about in the next session. You also have to establish a regulated area around the job or task, and keep determine if the PPE and hygiene requirements apply. We're going to talk about that in a second, as well as keep surfaces as free as practicable of accumulation of hexavalent chrome. And that language, for those of you who have worked with the lead standard, should be familiar. So respiratory protection, I'm not going to talk about a lot about that other than to say that you are required to use it if people are over the Pell and you're waiting to do your controls. The controls aren't feasible, or you can't get below the Pell, which in many of these operations can be very difficult to achieve the Pell. So respiratory protection might be a part of your life. Compliance with 1910-134 is necessary. This is something that the newer OSHA standards do. They simply defer to other existing standards for things like HAZCOM, respirators, PPE evaluations. There is no specification in the standard as to what type of respirator has to be used. Methods of compliance: if you're over the Pell, unlike lead, you don't have to develop a written control compliance program, but it's not saying that's not a good idea. But the burden is on the employer to show that a method of control is not feasible. So I'm not going to go through all of these things. This is stuff that Bob will be talking about too, other than to say that OSHA talks a lot in their preamble to the Hex Chrome standard about substituting other methods of welding and changing shielding gases as a method of reducing exposures. While these things work, you may have other requirements for your product that simply don't allow you to switch to, say, a TIG method from a MIG, or change your shielding gases to 100% argon from CO2. Those may not be feasible controls, but those are things OSHA specifically mentions in their standard as being controls. One thing that is unique about this standard, you can't use job rotation to achieve compliance. So that's a little bit different than some of the other substance-specific standards. Regulated areas: if you're over the PEL, you have to establish one, and it only applies to those areas, the job, the task, where exposures exceed the PEL. So let's say you have an occasional arc gouging process where you know you're over the PEL. You have to establish a regulated area around that process when it's being done. For many of you who have ongoing processes and booths where you're doing this kind of work, you may just have this sign, a demarcation set up permanently. OSHA doesn't say what that demarcation has to look like. You can use yellow tape, you can paint floors, you can do whatever you want, as long as it's clear to employees and other folks that that this is a regulated area and that access is limited. The other key thing is there's no eating, drinking, smoking, chewing tobacco or chewing gum, or application of cosmetics allowed within that regulated area. So it's really important that people just can't do any of that stuff in the regulated area, as long as that is a regulated area. You may have temporary regulated areas, and once that it's not a regulated area, it doesn't mean you can't do those things then. So let's talk about PPE, because this has, I think, been one of the more confusing parts of this standard. Unlike the lead standard, if you're familiar with that, the PPE requirements are not triggered by the airborne exposures. Now, again, if you're under 0.5, it doesn't matter because the standard doesn't apply at all. But the standard says that PPE is needed when there are skin or eye hazards possible, and it defers to the PPE standards for direction. So that kind of sets it up. But I think it's really important to remember that for most of the foundry operations that we're talking about here, the presence of hexavalent chromium as a skin hazard or eye hazard is pretty small. We're talking mainly about inhalation exposure. So I've put two things in here, and the reason I have both of these is they're kind of contradictory, and I haven't figured out how OSHA would approach this. But in their directive, and this is also in the preamble to the standard, they recognize that welding, and I would throw in the pouring and melting operations, because it's a very similar situation to welding, is that these things really don't cause dermatitis, that it's infrequent, and that there is not specific PPE required for hex chrome during these operations. And then they kind of said in an interpretation letter something a little different, that yeah, you may not, if they find any hex chrome on a surface in a wipe or bulk sample, then it does trigger the requirements. Again, I would argue that there isn't much of a skin hazard from these, but it wouldn't surprise me that you'd see differences of opinion amongst OSHA compliance officers based on these two different things they're saying. I think from an industrial hygiene standpoint, the position from their directive and preamble makes a whole lot more sense. So as we go into the next parts of the standard, which really are very costly and problematic, if you require PPE specific for the protection against hex chrome, it triggers all this other stuff. And if you only have exposure from welding, melting, pouring operations, I would argue that I don't think this stuff is needed. Now, again, it's not to say that a compliance officer might feel different. I think what I would emphasize, though, is the eating and drinking areas where people take their breaks and eat. I really think those should be kept very, very clean and free of hex chrome. It's easily removed by wet wiping surfaces and stuff, so there's really no reason that that's much of a burden to try to do. Housekeeping, the free is practicable of accumulations of hex chrome. This can be very difficult in a foundry. Certainly your sands and stuff aren't going to have the hex chrome. We're talking primarily about settled fume that may have hex chrome in it. You may want to think about grabbing some bulk samples and having them analyzed to see if there really is even any hex chrome in that settled dust. I've done that, and I just don't see a lot of hex chrome at all in settled dust. So if you have significant amounts of hex chrome, it has to be cleaned up, and you're not allowed to use compressed air to do that cleaning. It's very, very similar to the lead standard in that regard. But I think in most of the operations we're dealing with, there's just simply not much hexavalent chromium in that settled dust. Medical surveillance, this is a really busy slide, but I want to just hit upon a few important things. If you are triggered by it because you're over the action level for more than 30 days a year, you have to provide the medical surveillance within 30 days of assignment and annually. Unlike the lead standard, there's not a lot of prescriptive stuff in terms of what you have to do. There's no blood test. There's no urine test that's really very valid for hexavalent chromium. So really under the contents of the exam, we're talking about medical history, examination of skin and respiratory tract, and then the PLHCP may decide to do additional tests like pulmonary function or chest x-ray. It's not required, but the PLHCP may feel that that's important. There's a couple of other things over on the right-hand slide of what your duties and what you have to provide to the PLHCP about the exposures, and then they are required in turn to provide you with a written opinion as to whether or not the person can do that job. Employee information and training, this standard defers to the hazard communication standard. So if you have not included hexavalent chromium training in your HAZCOM program, you should, if you're over that, certainly over that 0.5 trigger level. There are several other things that are required in addition to the regular HAZCOM training, which deals with the health effects and where you can find it and all that sort of thing. But the additional requirements of the hex chrome standard is that employees have to demonstrate knowledge of the standard contents. In other words, that there is a standard and kind of a 30,000 feet view of what that standard requires. And they're also supposed to know about the purpose and description of the medical surveillance program. And you have to make a copy of the standard available to employees without cost. So whether or not you have a paper copy in some area where employees can access it, or you have it on a company intranet, it doesn't really matter. You have to provide a copy to the employees. This is another busy slide. I just want to hit upon a couple of important points. Exposure records, so any air monitoring that you've done or have done is supposed to include the things that are listed. I do find a lot of exposure records don't have all of this information, so it's very important that you do that. There was a big to-do about including employee social security numbers on these records. My suggestion is that you keep that separate from any reports that you may have generated internally or from a consultant, so that those numbers are secure. But somehow you need to be able to link that. Some people use clock numbers, which can be linked back to an employee's social security numbers. Different ways to do that without disclosing to everybody who could look at an exposure record somebody else's social security number. And like all exposure records, with a few exceptions, you have to maintain it for 30 years. There's some additional requirements on record keeping for medical surveillance. And then over on the other side, this all has to do with if you're using historical data or objective data to drive your Hexchrome program. If you're using your actual air sampling results to do that, you really don't have to pay any attention to that half of the slide. So what do you need to do? You need to review your operations to determine where potential exposures exist. And if you go back to those slides that talk about where you could have exposures, I think that's where you want to focus your efforts. Review your past monitoring data to determine, do you have enough information to characterize your exposures? You want to implement the provisions of the standard that apply to the exposure that you have, and be sure to maintain your records. A couple of resources that I put in here. The OSHA website has lots of very useful information on that first website that's listed. I will say that NIOSH, some of you may be familiar with this, NIOSH actually came out and recommended a much lower exposure limit for Hexchrome than OSHA did. And it's not going to be obviously enforced, but for those of you who want to really get to best practices, you could try getting to the NIOSH REL, which is, I believe it's 0.1. I haven't looked at it maybe it's 1. I'm not sure. It's a very low number, to say the least, and very hard to achieve. But there's a lot of good resources on the NIOSH website, particularly about toxicology of hexavalent chromium, if you're interested in that. So that's what I have now. I guess we'll take some questions, Shannon. I can't see the question thing on the side of my screen, so if you could read them off, I'd be happy to try to answer any questions.
Will do. We've got one question on board, and then anyone else still listening, if you have any more questions, please type them in the question box in the control panel. So, and while you're doing that, too, I wanted to remind everyone, Kay referenced the part 2 of this webinar. That's going to happen September 18th, so be on the lookout for that webinar. That's with Bob Scholes, and he's going to address some of the more control aspects of the standard. So let's see here. The first question, Kay, is plasma cutting of ductile iron castings, could that cause high exposure of chromium-6?
I would say my guess is, I don't have a lot of data on that. I would say it probably is not going to cause a lot. However, if you had very uncontrolled exposures, even that small amount of chromium that's in there could oxidize. It certainly will oxidize to hexchrome. The question is whether or not you can get enough of it. Manual plasma cutting is a very dirty process and generates just tremendous amounts of fume. It's not unusual to have overexposures to lots of other metals. I have not sampled personally for that. I'd be interested if anybody else has data on that. I would say it's probably not a bad idea to establish what that exposure is, and just at least have some comfort that it's not. But I would say it probably doesn't. You probably won't be over the Pell. Whether or not you could be over the action level, or importantly that trigger level for the standard, I think you should probably document that through some air sampling just to determine, again, making sure that you're sampling for that hex chrome separately from the other metals or total fume that you might in that sample. So I hope that answers the question.
Thanks, Kay. The next question is what kind of furnaces were studied for the stainless melting? Do you know if it was just induction furnaces or were there different types of furnaces?
You know, as I recall from that study, and if you want to go on, and it really wasn't a study, it was just reported results, but you can actually do an internet web search and find it. It was both AODs and induction furnaces that they were looking at. And if you do a search on SFSA, I hope I got the acronym correct, and the name Fiore, F-I-O-R-E, and if you do a search of that, you'll come up with a PDF document that has their numbers. And there's probably about, I don't know, 30 or 40 data points there, and most of them are related to melting and pouring. There's not as many for the arc gouging, welding, and plasma cutting, where, again, I think that's, from my perspective, that's really where you're going to have your significant hex chrome exposures are in those in your post-casting operations. But just do SFSA Fiore on a Google search, and you should come up with that document.
Thanks. The next question is, with a high variety foundry, how will I know when to conduct air monitoring? Due to different parts or alloys, there would be different results depending on what work is being done.
Well, there's a great question. I run into that whole issue with trying to do silica sampling. You know, you can do 10 silica samples in a row and they're all good, and then boom, you get some casting that has a weird shape or whatever, and all of a sudden you got problems. I guess how I would do that is I would start out trying to put a sampling strategy together, focusing on the alloys that have the highest chrome content and that you have, or have especially if you're going to be doing these post-casting type of operations, looking at which ones may have extensive repair welding, may require a lot more arc gouging or manual plasma cutting, trying to categorize them. And I'd start with the ones that seem to have the most potential and work your way backwards. And you know, if you get to somewhere along the line where you're just not finding it there, then I think you can say it's this kind of casting that's going to be a problem. But I think you start out looking for your worst case examples, and if you're under the exposure limits on your worst case, and you feel that you have good reason to believe that is your worst case, I think you're standing good that you don't have an issue with hex chrome. Obviously, if you're over the Pell or over the actual limit, that's a different story. But I think looking at the size and configuration of the casting, things that bring the employee very close to it, where the fume is going directly into their breathing zone, or processes that generate a lot of fume, those are the ones that you want to focus on, and the little ones you don't have to worry so much about. I hope that's a helpful answer.
Thanks, Kay. And now if anyone else has any questions, I'll give you a few seconds here to type them in. And again, a reminder that the next part 2 of the webinar series will be September 18th.
You know, I will mention on that last question, I have seen if you want a little bit more, I guess, idea of what OSHA is actually looking for, in the compliance directive, that CPL document, towards the middle section where they talk about, well, not the middle, it's in the section where they talk about exposure assessment. There's a rather good discussion on this issue of representative sampling and worst case sampling, that kind of concept there. And I think it would be really worth reading to see where they're coming from on that. And that may give you some really good indicators of how you want to structure your sampling strategy.
Thanks, Kay. Looks like we had one final question, and that was if there would be a link to the presentation. Yes, after the presentation is over and later on today or tomorrow, everyone who is attended the webinar will receive a link to the recording of the webinar. And if you want any more, further information, feel free to email me, Shannon Wetzel, and I can try to get you in touch with Kay if she can help out with any other additional information.
Be happy to do that.
So,
and again, I apologize for my technical glitches on my end.
well, I'm glad we got it in, and I think it went okay. So thank you again, Kay, for the very informative webinar on this important topic. And thank you all in the audience who stuck around through the delay and got to listen to this important webinar. So everyone have a great rest of your Thursday. And thanks again, Kay.
Yep, you're welcome.
Take care.